Hello everyone, I am Ronald P. Saladaga and I will discuss about the Terzaghi's ultimate bearing capacity theory. Now before we go straight to the theory itself, let us have a brief recap first on the loading and foundations. So there are two types of loadings in foundation. First is the centrically loaded and the eccentrically loaded shallow foundation. Now in centrically loaded shallow foundation, there is no moment occurring, and so the summation forces in terms of y-axis is equal to 0 and the summation of moment is equal to 0. However, in the eccentrically loaded shallow foundation, there is a moment, and so the summation forces is still equal to 0. However, the moment is not equal to 0 because there is a moment occurring. In this topic, we will only focus on the eccentrically loaded shallow foundation. So, which means that our forces is equal to 0 and our moment is equal to 0. Now, Terzaghi has stated a foundation may be defined as a shallow foundation in the depth df is less than or equal to its width d. So, which means na kaning depth diri from the top of the soil up to the bottom of your footing is not dapat daw dili siya mas mo taas sa imong width sa imong footing. Also, he stated that assume that for the ultimate soil bearing capacity calculations, the weight of the soil above the base of the footing may be replaced by a uniform surcharge Q, which is equal to gamma dF. So basically, ang Q surcharge daw nimo is equal to the gamma of the soil kinin nasa taas, top of the soil padulong sa bottom of your footing. So manada siya imong Q drop. So in the failure mechanism that Terzaghi assumed for determining the ultimate soil bearing capacity or general shear failure is shown in the figure 16.5. So diri makita nato nga naay lahi-lahi nga zone. Na ay zone 1, zone 2, and zone 3. So ang zone 1 daw ginatawag na elastic zone, ang zone 2 ginatawag na radial zone, and zone 3 kay ginatawag na Rankine passive zone. However, in Terzaghi, pagkuha niya sa iyang equation, ang iyang gigamit is ang zone 1 lang. So i-zoom in nato si zone 1 para makita nato ang mga forces nga nag-act sa iya. And so diri makita na to nga C, basta matingala mo, ano na himo siyang B over cosine phi prime. Actually, gikuan na siya, gihimo ra siyang right triangle, gi-half siya, gito nga. So, maka-generate og right triangle with the adjacent side of B and the hypotenuse of AJ. And so, maka-create ang formula na cosine phi prime is equal to B over AJ. Isolate na to si AJ, generate siya og B over cosine phi prime. And so, i-substitute atong value ni AJ din So, ang value sa C is equal to C prime B over cosine phi prime. And so, mag-summation forces Y is equal to 0 ta. So, ang formula kay nahimong QU times 2B times 1 is equal to negative W kay downward ang force niya plus 2 sin phi prime. Si phi prime kay naka inclined man ang force niya, so kung na to iyang atong force niya nga nag-act lang sa y-axis, and plus pp or the passive pressure, where ang atong B dara kay B over 2, atong W kay gamma B squared tangent phi prime, and atong C kay kini siya C prime B over cosine phi prime. So substituting the values, makuha na to ni nga formula. And simplifying, QU lang mabilin sa left side, kini na siya may tabo. And so nag-state po si Terzaghi diri nga the passive pressure is the sum of the contribution of the weight of the soil gamma, cohesion C prime, and surcharge Q, and can be expressed as kini siya P is equal to 1/2 gamma times B tangent phi prime squared ky k gamma plus c prime times b tangent phi prime kc plus q b tangent phi prime kq, where ang ato ang kc, ky, and kq are earth pressure coefficients that are functions of the soil friction phi prime. And so, substituting the values of pp to the previous equation, kini siya nga equation, substitute nato si pp diri. Nakuha nato ang formula nga kini. Qu is equal to c prime nc plus qnq plus 1/2 gamma b and y, where ang nc nato kay tangent phi prime kc plus 1, ang nq kay kq tangent phi prime, ang ny kay 1/2 tangent phi prime ky tangent phi prime minus 1. Kini siya nga formula, qu is equal to c prime nc plus qnq plus 1/2 gamma b and y kay ginagamit na siya for strip footing equation. O kini siya nga formula mo na yun siya ang Terzaghi's equation. And so, ingon si Terzaghi nga the values of the bearing capacity factors NC, NQ, and NY depends on the value of the phi prime which are given in the table. So, kani siya, giandam na ni Terzaghi daan nga every value of phi prime na corresponding value ni NC, NQ, and NY. So, mani siya. For example, atong phi prime kay equal to 5. So, ato ang NC kay 7.34, NQ kay 1.64, and ato ang NY is 0.14. However, pag dili ni siya given na table, natay mga corresponding formulas for NQ, NC, and NY. Now, for NQ, gamito na to ang formula ni Restner in 1924, tangent squared of 45 plus phi over 2 times E. Kini siya nga E, di na siya void ratio. Paano siya? Exponential ni siya sa calculator. E raised to the power of pi tangent phi. Ang atong NC is equal to NQ minus 1 times cotangent phi. And our NY is equal to 2 NQ plus 1 tangent phi. Ang NC kay gikan kay formula ni Prandtl in 1921 and kining NY kay gikan kay Basic in 1973. Now, Terzaghi suggested the equations for square and circle equation, which are kini siya: square footing QU is equal to 1.3 C prime NC plus Q NQ plus 0.4 gamma B and Y. Now, for circular footing, halos same lang sila, naglahi lang is sa last part, 0.3 na siya instead of 0.4. Now, wala gihatag ni Terzaghi ang rectangular footing. However, given siya sa ubang libro, so giapil lang ko siya diri. So, ang rectangular footing daw kay QU is equal to C prime NC times 1 plus 0.3 B over L, where ato ang L diri kay mas larger than B. So, ibig sabihin ang B kay smaller value than the L. So, plus Q and Q plus 0.5 gamma B and Y times 1 minus 0.2 B over L. Next, let's have the difference between the modes of shear failure. Kabalo na ta kung gawin sa pagkuha sa Terzaghi's ultimate bearing capacity equation. Now, let's differentiate the modes of shear failure. Now, naay tulo ka types sa modes of shear failure, which are the general, local, and punching shear. Now, makita na to diri sa figure sa left na in general shear failure, in the load settlement diagram, makita na to diri nga as load increases, hinay lang iyang pag-settle. Pag-abot niya sa peak load, dira magdiretso-diretso na siya og settle. Now, in local shear failure, as load increases, settlement also increases at almost the same rate. Now, pag maabot na po niya tong peak load niya, dira magdiretso-diretso na po siya settle. However, in the punching shear failure, halos tuloy-tuloy iyahang pag-settle as load increases. So, kini siya ang summary sa different modes of shear failure. So, in relative settlement, ang general daw kay less lang daw ang pag-settle, sa local and sa punching kay large. In bulging naman, ang general shear failure, significant iyang pag-bulge. Makita na to diriya sa figure, sa left, na nag-bulge jud siya maayo. Sa local is less lang, nga mayroon to makita na bulging. And sa punching is wala jud kay makita na bulging. Na in tilting and footing, sa general, expected yun siya kay makita niya itong nag-bulge siya. So, makabalot ang matilt niya siya. Then, sa local is di kaya na to makita kay gamay lang yung pag-bulge. And sa punching, di nyo na to siya ma-expect kaya wala yung siya bulging nga natitabo. In ultimate load, so sa general kay well-defined, sa local kay not well-defined, and sa punching kay not well-defined also. So, in the failure pattern, na siya wedge, na slip surface, and also bulging. Now, sa local, nandiyan po siya wedge, slip surface, however, dili kayo makikita yung bulging. And in the punching shear failure, not well-defined yung failure pattern. Now, the general shear failure occurs in a dense type of soil. The local occurs in a less compressive soil type. And punching occurs in a highly compressive soil type. So that's the difference between the modes of shear failure. However, we will focus only on general shear failure and the local shear failure. Now, what are the difference between the two? So, in considering the possible local shear failure, angle of internal friction phi and cohesion C should be modified. So, tangent phi prime is equal to 2/3 sa tangent phi. And C prime is equal to 2/3 sa C, where ang ato ang kananay mga prime kay local shear and kanang mga walay mga prime kay general shear. So, ang ato ang formula for general shear failure may differ in local shear failure. Napulihan lang kay ang prime, which ang prime diri kay laylay og values. Pareho siya actually og formula, pero lahi lang ang value sa ato ang C prime and C prime and Q prime and BY prime.
Good day, everyone. I am King Haron M. Sultan. In addition to what Mr. Saladaga have discussed, let us talk about what is a foundation. Simply put, a foundation is a part of a structure. It transmits load from the structure itself to a substructure, which in this case is the soil. There are two types of foundation: shallow foundation and deep foundation. In the shallow foundation, the ratio between the depth of the foundation and the base is less than or equal to 4. In deep foundation, on the other hand, the ratio between the depth of the foundation and the base is greater than 4. So it is a job of an engineer to design a foundation to ensure that the foundation will not undergo shear failure or excessive settlement. Terzaghi's ultimate shear capacity theory is belongs to the shallow foundation. Terzaghi have three equations depending on the shape of the foundation, which was discussed earlier by Mr. Saladaga. So now, let us have an example.
Good day, everyone. I am Katina Petrache. So, my groupmate already discussed the concept of Terzaghi's ultimate bearing capacity theory. So now, I will give an example. So, for example, problem number 1, a square footing for commercial building has a dimension of 2 meters by 2 meters, is founded 1.5 meters below the ground surface. Unit weight of the soil is 18 kilonewton per meter cube with a cohesion of 10 kilopascal. Under the condition of general shear failure, A. Compute the angle of internal friction of the bearing capacity factor NQ is equal to 3.94, and B. Compute the ultimate bearing capacity in kilopascal. Use Terzaghi equation.
Now we have the given of df, or the depth, is equal to 1.5 meters, b of 2 meters, unit weight 18 kilonewton per meter cube, and the c, or the cohesion, is equal to 10 kilopascal. So the first question is, we need to find the angle of internal friction with the given bearing capacity factor NQ is equal to 3.94. So in this case, we need to use the Resner formula, which is so we just substitute the NQ, which is 3.94, and then the unknown will be the angle of friction. So this will be the equation in order to find the angle of friction. So in computing 3.94, now we have 14.9969, or 15 degrees. So now we have the angle of internal friction of 15 degrees. Next, we need to find the ultimate bearing capacity in kilopascal. So since this footing is a square footing, we need to use the square footing formula in general shear failure. So we have this formula. So we all know that we have the value for C, which is 10, the NQ, which is 3.94, the unit weight, which is 18, and the B, or the base of the footing, is 2 meters. Now the missing values is, in order to get the ultimate bearing capacity, is NC, Q, and NY. So to get these three missing values, we will use first, for NC, we will use Lagrange formula, which is NC is equal to NQ minus 1 cotangent angle of internal friction. So we have the value of NQ and the angle of internal friction. But in using the calculator, there is no function of cotangent. But we all know that cotangent is also equal to cos x, or the angle of internal friction, over sine of angle of internal friction. So we can use this as the cotangent angle of internal friction in calculating in the calculator. So in calculating, we now have NC is equal to NC is equal to 10.972. Now we have the value of NC. Next, we need to get the Q. So we all know from the previous discussion, which is about the concept, that Q is equal to gamma, or the unit weight, times the df, or the depth. So we have values for this gamma and df, so isa substitute lang natin. So we have already the values for these two, so we need to substitute diretso. We have 18 times 1.5. Q is equal to 27. Now we have Q. The last one, we need to compute the NY. So for NY, we will use the basic formula, which is this one. So we have the value for NQ and the angle of internal friction, so substitute. Now we have the value for NY, which is 2.647. Now we can substitute the ultimate bearing capacity by substituting all the values in this equation. So to calculate, we have the ultimate bearing capacity of 287.133 kilopascal. So this will be the final answer. Thank you.
Hello, King Haran here, back at it again with another example. So sample problem number 2. A footing for an institutional building has a dimension of 2 meters by 2 meters with a depth of 1.5 meters. Given the unit weight of the soil 18 kN per cubic meter, cohesion of 30 kPa, and angle of internal friction 30 degrees, using Terzaghi's equation, determine the following. A. Ultimate bearing capacity denoted as small qu, allowable bearing capacity denoted as q allowed, and allowable load denoted as capital Q allowed, with a factor of safety 2.5. Solution for sample problem number 2. So first step, what we want to do is draw the figure for the foundation. And take note of given the unit weight of the soil, 18 kilonewton per cubic meter, cohesion C is equal to 30 kPa, and angle of internal friction 30 degrees. So using A, ultimate bearing capacity, using Terzaghi's equation. So using the formula QU so B here is the base and the L is the length, so like this. So since B divided by L is equal to 2 over 2, which is equal to 1, therefore we can simplify the equation. So 1 man siya, kanipod 1, so 1 plus 0.3, so 1.3 CNC plus QNQ plus, so 1 minus 0.2, so 0.8 times 1/2, so 0.4. Unit weight B N into 8. So kani siya nga equation familiar na niya siya, mao ito siya sa square. So dirito nagikan ang square nga equation. So since given ato ang angle of internal friction, dayon naatay table ganiha nga katong gi-present. I-link lang nako sa i-post lang nako sa Blackboard. So ang value sa kaning factors NC, NQ, and N gamma. Okay, makita na siya sa table kung 30 degrees ang internal friction. So, sa table, ang value sa NC kung 30 kay 37.16, NQ kay 22.46, and ang N gamma is 19.13. So, substituting the values, ang Q ani is stress sa base due to the unit weight sa soil o iyang depth. So therefore 18 times ang depth of the foundation na 1.5. So 1.5 times NQ plus 0.4 18 to so ang atong ultimate bearing capacity is equal to 2331.132 kPa. So mo ni answer sa A. Sa B, allowable bearing capacity. So ang allowable bearing capacity is just Q, ultimate bearing capacity, divided by the safety factor. So therefore Q allowed is equal to 2331. Therefore natin Q allowed nga 932.453 kPa. Ang atong allowable load is simply Q allowed times the area of the foundation, AF. So therefore 932.453 times area 2 times 2. So ang atong Q cloud is 3729.812. So since area man ni siya, then ang atong ultimate bearing capacity is kPa. Therefore, ang unit ani is kilonewton na lang.
So, hi everyone, I am Marie Quijano. So, ito yung other example natin. So, example is, a square footing 2 meter on the side is founded 1.2 meter below the ground surface, for which the book unit weight of soil is 20 kilonewton per cubic meter. The cohesion strength is 10 kPa and the angle of internal friction is 15 degrees. Under the condition of general shear failure, evaluate the soil bearing capacity in kilopascal. Use Terzaghi's bearing capacity factors. So number 1, if the groundwater table is more than 2 meter below the bottom of the footing. Number 2, if the groundwater table is at the bottom of the footing. Number 3, if the groundwater table rises to the ground surface. So, number 1. Solve natin yung number 1. So, in number 1, if the groundwater table is more than 2 meter below the bottom of the footing. So, first natin gagawin dito is, kukunin muna natin yung bearing capacity factors. So, paano natin makukuha yung bearing capacity factors? So, itong mga bearing capacity factors, ito yung mga NC, yung NQ, tsaka yung NY. So, makukuha natin yung bearing capacity factors using the table of Terzaghi's bearing capacity factors. So, ito yon. Ito yung Terzaghi's bearing capacity factors. So, sinasabi doon is, the internal friction is 15 degrees. So, ito. Dito yung internal friction, tsaka yung NC, yung NQ, tsaka yung NY. Tapos, ito, internal friction. So, since 15 degrees, so hahanapin natin yung 15 degrees dito. So, 15 degrees. So, dito sa 15 degrees, ito siya. Ito. So, 12.86 yung NC natin. So, NC natin is, lagay natin dito is 12.86. Tsaka yung NQ natin is, ito, 4.45. Ito, 4.45. So, NQ natin is 4.45. Tsaka yung NY natin is, ito, 1.52. 1.52. So, since kompleto na yung mga bearing capacity factors natin, so, susulat muna natin yung given. The cohesion of the soil is, alam nga yung cohesion of the soil? 10 kPa. So, 10 kPa. Yung B natin, which is the width of the square footing is 2 meters. And the unit weight of the soil is 20 kilonewton per cubic meter. So, yan na. So, etong DF natin is the depth of the footing beam, which is galing siya sa ground surface hanggang sa bottom ng ating footing beam. So, ito. So, galing dito, ito siya. Galing dito hanggang dito sa pinaka-bottom. Yan yung DF natin, which is given siya sa problem, which is 1.2 meters. So, 1.2 meters. So, dito sa problem number 1, if the groundwater table is more than 2 meters below the bottom of the footing. So, galing daw dito sa bottom of the footing, papunta sa water table, it is more than 2 meters siya. Tsaka yung, di ba, yung width natin is B is equal to 2 meters. So, yan na, draw na natin. Ang next na naman na gagawin natin is the modification of bearing capacity equations due to the presence of water table, which is yung didetermine natin siya kung case 1 ba siya, case 2 ba siya, case 3 ba siya, case 4 ba siya. So, dito is, ito ay case 3. Bakit siya case 3? Kasi, sa case 3, ito yung case 3. Sa case 3 is, for water table located so that the D is greater than the B. Diba sabi doon is, yung D natin is the distance between the water table hanggang sa bottom of the footing beam natin. So, since more than 2 meters man daw siya, so, dito siya sa case 3. D is more than B. So, ito yung gagamitin natin. So, Q natin, to get the Q, yung Q is the effective surcharge. To get the Q of the, so case 3 yung gagamitin natin na formula ha. So, unit weight multiplied by the depth of the footing beam. Then, the ultimate bearing capacity is equal to 1.3 C, which NC plus Q NQ plus 0.40 unit weight of water, the width multiplied by the NY. So, solve na natin. So, first is kukunin muna natin ang effective surcharge. So, Q is equal to unit weight of water multiplied by the depth of footing beam. So, Q is equal to unit weight of water, which is 20 multiplied by the DF, which is 1.2 meter. So, yun. 20 times 1.2 is equal to 24. So, Q natin is equal to 24. Then, makukuha na natin yung ultimate bearing capacity, which is 1.3 multiplied by the cohesion natin, 10, times NC, which is 12.86, plus yung Q natin na ito, 24, multiplied by NQ, which is 4.45, plus 0.40. The unit weight of soil natin, unit weight of soil is 20 multiplied by the width, which is 2 meters, and the NY is 1.52. So, yung ultimate bearing capacity natin is 1.3 multiplied by 10 times 12.86 plus 24 multiplied by 4.45 plus 0.4 multiplied by 20 multiplied by 2 multiplied by 1.52. So, 298.3 kPa. So, ito na yung A natin, which is case 3 siya. So, next is number 2. If the groundwater table is at the bottom of the footing, so, nakuha naman natin yung NC. Meron na tayong value ng NC, which is 12.86. The NQ is 4.45. The NY is equal to 1.52. Tsaka yung C, 10 kPa. B is 2 meters. Unit weight of soil is 20 kilonewton per cubic meter. So, yan na. So, next is, yun. I-determine natin kung anong case to. So, if the groundwater table is at the bottom of the footing, so, yung water table natin, tsaka yung ilalim ng footing natin is, bottom of the footing natin is, siya, same distance siya, or ayun, the ground of water is at the bottom of the footing. So, ito siya, ganito siya. Ito yung water table natin, andyan yung bottom ng footing natin. So, next is, ano bang case to? So, ito ay case 4. Bakit siya case 4? Kasi dun sa case 4 natin, for water table located at the bottom of the foundation. So, di ba? At the bottom of the footing. Ito yung, natin, number 2. So, case 4 siya. So, paano natin isosolve yung case 4? So, to get the Q is equal to unit weight multiplied by dF, then the ultimate bearing capacity is equal to 1.3 CNC. Same lang dun sa formula. Q and Q plus 0.4 unit weight. The width multiplied by the NY. Where ito, yung natin dito, unit weight is equal to Y sat minus the unit weight of water. So, first muna natin is, kukunin natin yung Q. So, Q is equal to unit weight of water, 20, same pa rin, multiplied by 1.2, the DF. Diba, DF natin dito is 1.2, then the B natin is 2. So, Q is equal to, ilan nga yun? 20 times 1.2, 24. Then, kunin na natin muna yung unit weight natin, which is Y sat minus unit weight of water, which is, Y sat natin is 20 minus unit weight of water, 9.81. So, yung gagamitin na natin na unit weight is 20 minus 9.81 is equals to 10.19 kilonewton per cubic meter. So, kukunin na natin, makukuha na natin yung ultimate bearing capacity, which is 1.3 multiplied by the cohesion, which is 10, the NC, which is 12.86, plus the Q, which is 24, multiplied by the NQ, which is 4.45, plus the 0.4 multiplied by the unit weight. Ito na yung gagamitin natin. 10.19 multiplied by the width 2 multiplied by the NY, which is 1.52. So, Q ultimate bearing capacity natin is 1.3 times 10 times 12.86 plus 24, 4.45 plus 0.4 multiplied by 10.19 multiplied by 2 times 1.52. So, 286.371 kPa. So, ito na yung sagot. So, number 3. Ito yung number 3. If the groundwater table rises to the ground surface. So, yung groundwater table natin tsaka yung ground surface natin is magka-level sila. So, anong case to? Case 1 to siya. Bakit siya case 1? Kasi, di ba yung case 1 natin is dapat yung D1, which is yung D1 natin is distance ng ground surface papuntang water table is less than the DF natin. Yung distance mula sa ground surface papunta sa bottom ng footing natin. So, dito, magka-level man yung water table natin tsaka ground surface, therefore, yung D1 natin dito is equal to 0. Diba? Then, DF natin 1.2 pa rin. The beam is 2 2. Tsaka yung C natin 10, 2, tsaka 20 kilonewton per cubic meter yung unit weight natin, KPA. Tsaka yung NC natin, yun pa rin yung gagamitin natin kasi 15 degrees, 12.86, 4.45, tsaka yung NY natin is 1.52. So, yung formula na gagamitin natin para makuha yung Q natin, which is the effective surcharge, is Q is equal to D1 unit weight plus D2 Y sat minus unit weight of water. Then ultimate bearing capacity is equal to 1.3 C and C, yun pa rin siya, Q and Q plus 0.40 unit weight multiplied by the width, then multiplied by NY, which is, yung ito na naman natin, yung unit weight natin is Y sat minus unit weight of water. Or the unit weight, saturated unit weight, minus the unit weight of water. So, yung Q natin, first natin kukunin yung Q. So, D1, di ba 0 na to? So, 0 na to siya. 0. So, dito na tayo, D2 multiplied by Y sat minus Y, unit weight of water. So, yung dito pala natin is yung distance mula sa water table papuntang bottom ng footing beam, ng bottom ng footing natin. From distance ng water table papuntang bottom ng footing beam natin, yun yung D2. So, yung D2 natin dito is from water table papunta sa bottom ng footing natin. So, therefore, yung D2 natin is equal to 1.2. So, 1.2 multiplied by saturated unit weight natin, which is 20 minus unit weight of water is 9.81. So, 1.2 multiplied by 20 minus 9.81, 12.228 yung effective surcharge natin. Then, kukunin muna natin yung unit weight na gagamitin natin. So, unit weight is, yun pa rin, Y sat, which is 20 minus 9.81. So, yung gagamitin natin is 20 minus 9.81, 10.19 kilonewton per cubic meter. Then, kukunin na natin yung ultimate bearing capacity, which is 1.3 multiplied by 10 multiplied by NC, which is 12.86 plus Q natin, which is, ilan nga yung Q natin? Ito, 12.228 multiplied by the NQ, which is 4.45 plus 0.40. Unit weight na gagamitin natin is ito, 10.19 multiplied by the width natin, 2 times the NY, which is 1.52. So, ultimate bearing capacity natin is 1.3 multiplied by 10 times 12.86 plus 12.228 multiplied by 4.45 plus 0.40 multiplied by 10.19 multiplied by 2 multiplied by 1.52. So, therefore, yung sagot natin is 233.986 kPa. So, ito na yung sagot natin. Thank you!